So hello everyone, how are you? I'm Dr. Shariful Halim and today I'm going to talk about common statistical tests. So here we have three common statistical tests, and the first one of the very important one is t-test. So t-test is a very important test that actually checks the difference between means or averages of two groups. And for remembering it, there is a mnemonic from first aid, which is T is meant for two. And one common example is comparing the mean blood pressure between men and women. So here there are two groups, one is man, another is women. So two groups, and you are comparing the mean between those two groups. So you're using the t-test. ANOVA, or analysis of variance, is another commonly used test which actually checks difference between more than two, meaning three or more groups. So for remembering it, you can see that analysis of variance actually has three words: analysis of variance. So from that you can remember that ANOVA is used for three groups. And one common example is comparing the mean blood pressure between members of three different ethnic groups. Another important test is chi-square, and it checks the difference between two or more percentages or proportions. Very important. So t-test and ANOVA, both of them actually measures the means, compare the means. But in case of chi-square, you do not compare the mean. You compare the percentages or proportion of categorical outcomes. And you can remember it by pronouncing the chi-square as categorical. One example would be comparing the percentage of members of three different ethnic groups who have essential hypertension. So you have three groups and you are comparing, not comparing means, you are comparing the percentage of members. So that should be the key of this question or this example. So here is a single case that I brought from BRS for explaining every type of test. Suppose a consumer group would like to evaluate the success of three different commercial weight loss programs. To do this, subjects are assigned to one of the three programs. One is Group A, another is Group B, and another is Group C. The average weight of the subjects in each of the three groups is not significantly different at the start of the study, which is time 1. Each group follows a different diet regimen, and at time 1 and the end of 6-week study, time 2, the subjects are weighed and their blood pressure measurements are obtained. So how can we use t-test in this study? So t-test can tell you the difference between the means of two samples, or can compare the means between two samples. So t-test can be independent t-test or dependent t-test. So independent t-test is, it tests the mean difference in body weights of subjects of Group 1, Group A and subject in Group B at time 1. So when does it become independent? Independent is when you measure the difference for one occasion in two groups of subjects. So two groups in one occasion is independent t-test or non-paired t-test. But when you test the mean difference in body weights of people Group A at time 1 and time 2, it becomes a dependent t-test, or is called a dependent t-test or paired t-test. Why did it called paired t-test? Because the same people are sampled on two occasions. So actually non-paired and paired actually depends on occasion. So non-paired on occasion, paired two occasions. So a pair is 2, so you have two occasion measurement of the value in two occasions. So that should help you remember. So how can you use ANOVA? So here in ANOVA we actually can measure the difference among the groups, mean of the groups of more than two samples or three or more than three. So 3 should be the key. So in case of one-way ANOVA, it tests the mean difference in body weights of subjects in Group A, Group B and Group C at time 2. So we have one variable here, which is only group. So we are measuring difference in means in three groups, A, B, C. So for three groups we need 3-word test, which is ANOVA, and this is called one-way ANOVA because only one variable here, that is group. And two-way ANOVA is when you have two variables. Suppose the test, suppose you are testing the mean differences in body weights of men and women. So this is one type of variable, which is 6, and in difference in body weights of Group A, B and C, which is another variable, which is group. So you are doing with two variables. One variable is sex, another variable is group, and that's why it's called a two-way ANOVA. How can you chi-square test here? chi-square measures the difference between frequencies in a sample, and the test, the chi-square can be used as a difference among a percentage of subjects with body weight of more than 140 pounds or less in group A, B, C at time 2. So we are measuring the percentage of subjects. We are not measuring the means between subjects. We are measuring the percentage of subjects who have a body weight of more than 140 pounds or less. So let's just solve a problem together. Suppose a study is conducted assessing relationship between smoking status and forced expiratory flow between 25% and 75% of vital capacity, which is called FAF 25-75, in 4 groups. So we have 4 groups, and we are actually comparing those 4 groups. The group A consists of 200 non-smokers, group B consists of 200 light smokers, group C 200 moderate smokers, and group D consists of 200 heavy smokers. So different type of smokers in 4 groups. And then FAF 25-75 is measured in all participants. And which of the following is the most appropriate statistical method to compare the FAF 25-75 result among all 4 groups? So what it tells me, what it asks to measure the difference of means, which is mean of FAF 25-75 among more than 3 groups, which is 4 groups. So what test we order? We order analysis of variance, or ANOVA. So this question is from UWorld. I think this video helped you, and that's all from me today. Thanks all for watching my video.